Hello everybody and welcome back to Let's Practice on the subject of two first-degree equations with two variables. And we have here practice number 2. Let's see what we're going to do here. Here we have an interesting situation. Let's see where it leads. Let's deal with this equation first. Okay, I can see that if I will multiply this by 2 over 2, I can make this thing to have the same common denominator, right? Now it's have the same common denominator. And let's make the fractions go together. Yes. And multiply everything by 6. Now I have a flat equation. Let's do some rearrangement. And now I have a straight line equation, right? With a slope of -8 and an intersection point with the y-axis of y equal to 6. And let's do something interesting. I can see that I can easily do a substitution. I can substitute this y right here with this value right here. I'm just going to place 6 minus 8x instead of this y. Why? Why I can do that? Because remember, in the intersection point, the lines have the same point, the same x and same y. So after I do that, I get what I have right here. Now, let's solve this equation. Let's do a common denominator, and I get to this multiplied by 4, and I have this flat equation. Open the parentheses and do some rearrangement, and I get that x is equal to 1. Now we're going to use this x, I'm going to plug it back right here, and find the y. So I have the solution, x equal to 1 and y equal to -2. So thank you very much. Let's do another one. All right, what do we have here? Oh, interesting. Here we have a classical situation when I have one fraction on the left and one fraction on the right. So you know what I like to do when I get to this diagonal multiplication. If you don't remember what diagonal multiplication is, please check out my first playlist on one first-degree equation with one variable. I'm explaining that over there. So, but basically, if you don't want to do that, you don't have to. Basically, it's multiplying this part by this part and multiplying this part by that part, giving me this. And then I can open the parentheses, do some rearrangement, and get to some kind of a shape where y is isolated, like that. On the right side, I took the liberty to give you a chance to try it yourself, and this is where you need to go. Okay, so do it yourself, pause the video, try it, and we'll see you in a couple of minutes. All right, you did it. So what do we have here? We have a situation where if I'm going to multiply this -6y by a half, I'm going to get the opposite sign of 3y. Okay, so let's do it. And then we're going to use the addition subtraction tool. All right, we did it. Now let's put them on top of each other. If I'm going to add this part to this part, it will be equal to the addition of this part to this part. I'm still maintaining the equality by the addition or subtraction. But here we're going to do an addition. So let's do the addition. Add them up, and 3y minus 3y is 0. Excuse me, I want to say it right. 3y plus minus 3y is 0. And minus 5x plus 23x is 18x. And minus 6 plus 6c is 54. So we reached our goal. We have a single variable solution, and we did it by addition and subtraction, excuse me. Okay, so after a few manipulations, we're going to find that x is equal to -3. Then we're going to plug it back to this equation right here, and we're going to find the y, and we find that our y is equal to 3. So our solution is -3 and 3. So I hope you enjoy practice number 2. I'm going to see you at practice number 3. Give me a like, subscribe, tell to your friends. Guys, See you later.